calculate each of the following hexadecimal arithmetic. So here we have some hexadecimal numbers that we are going to carry out some operations. The first one, we are going to add the hexadecimal numbers, and the second one, we are going to subtract the hexadecimal numbers. And these number system arithmetics are highly tested in the exam. So you have to familiarize yourself with octo arithmetic, with this hexadecimal arithmetic, binary arithmetic. Also, you have to look at we have octo, we have binary, we have decimal. In decimal, this is the normal arithmetic that we do for numbers. So if it is multiplication, it is the symbol multiplication that we have done in all the levels of academic, from primary schools and all that. But now when we come to the other systems like octo, binary, and hexadecimal, there are some specific rules that you have to note. And it is not hard, because we are going to see now how in hexadecimal we do them. So the Roman one is hexadecimal addition, and the second one is hexadecimal subtraction. So first of all, as we start, note that hexadecimal numbers, these are numbers of base 16, and these numbers, they run from 0 to 15. And this is the numbers. We have 0, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. In hexadecimal numbers, when you reach 9, you don't write 10, you start from A, B, C, D, E, F, whereby this is representing 10, this is representing 11, this is 12, this is 13, this is 14, and this is 15. And that is why we are saying they run from 0 to 15. So those are hexadecimal numbers. Now we have the Roman one. We are given ADC, and this is being added to 12E. So this is how you do it. The first, here we add each digit, and if there is a carry, we carry, and so forth. So in the first column, we are adding C and E. Now when you are doing this, you look at the equivalents for C and E. C is representing 12, and E is representing 14. So 12 plus 14 gives us what? 26. Gives us 26. And as you can see, 26 is not among the 15 digits of hexadecimal numbers. So this 26, in base 16, it can be written as 1 times 16 plus 10. So 1 times 16 plus 10. So when you get any number that is above 15, you break it in base of 16, 1 times or 2 times 16, and so forth. Because if we had reached above 30, we could have written 2 times 16 plus whatever. So in this case, 26 can be broke up in 1 times 16 plus 10, where now 16 here is power 1. So in this case, 10 becomes the sum, and this one which we have multiplied with the base of 16 becomes the carry. Remember, for example, if we are adding decimal numbers, for example 25 plus 26, if we add 5 plus 6, we get 11. So we don't write 11. So because it is above 10, we carry a 1. So if it is above 15, because we are looking at hexadecimal numbers, if it is above 15, it means there is a carry. So the carry here for 26 will be 1, and the sum now, what we will write at this position is then the added number. So in this case, we don't write the sum 10, but we look at the equivalent for 10, and the equivalent for 10 is a. So in that case, we get a, and we carry 1. We carry 1 at that point. Now in the second column from right, we are having a 1 plus d plus 2. So this is equivalent to 1 plus d is representing 13. So this is 13, and we add 2. In this case, we are going to get 16. So remember, here in hexadecimal numbers, we have 0 to 15, which is a total of 16 digits. So 16 can be broken up into 1 times 16 plus 0. So this becomes a carry because the number is above 15. So this is the carry, and this is the sum. So in this case, the sum is taken now at this point, at the middle column, and the carry is taken to the other column. So we carry 1. So in the third case, we are now having a 1 plus a plus 1. 1 plus a plus 1, it is the same as 1 plus a is 10 plus 1, and this is giving us 12. In this case now, 12 is within 0 to 15, so we just look at the equivalent for 12 is c. Remember, we are dealing with hexadecimal numbers, so we cannot write 12 here, but we are going to look at what represents 12 in hexadecimal numbers. So that is c. So we write c there. So in this case, ADC plus 12e, we get C0a base 16. So that is the answer for Roman 1. For Roman 2, this is subtraction. Then we have 24CB. 24CB, we are subtracting 111E. 111E. So as usual, the way we do for decimal numbers or normal numbers, that is base 10, when the numbers are not is not possible to subtract them, we carry from the next number. So in this case now, we have our sum. or our problem. So in this case now, let's go step by step. We are going to consider our column that we wrote here from 0 to 15. So in the first column, we are having a B minus a E. So let's write the equivalence of this. B is represented by 11 and E is 14. So in this case, we know we cannot subtract 11 from 14, as we know from normal subtraction. So for example, as you cannot subtract 5 from 6, you have to borrow. Here B and E, B is smaller than E, so 11 cannot be we cannot subtract 14 from 11. So we have to borrow. And remember, the base that you are dealing with, if it is base, for example, it is base 8 octal, when you borrow a 8. So in this case, when you borrow in hexadecimal number, we borrow a 16. And this is what happens also in normal numbers. For example, if we are having 13 minus 2, 6. 3 minus 6, we borrow here and we get 13, meaning we have borrowed a whole 10. So in this case now, we borrow 16 from C. We are borrowing 16 from C. So we borrow 16 from C, which is in the next column. So in this case now, when we borrow 16 from C, we are going to have we add it to B now. So we are going to have our 16, which we have borrowed, plus our B, which is 11, and this one will give us 27. So now in this case now, we are going to take the 27. We subtract now our E, which is 14. And in this case, we get 27 minus 14 is 13. And this case, 13 is represented by D. So in this case now, B minus E, we are going to write D in this case. Remember, we borrowed from C. So we borrowed from C, and the C is 12. C is 12. So when we borrow 16, we are going to remain with B. The way we subtract in normal numbers, when you borrow, you decrease the number by 1. Let me put it clear. For instance, if we have, for example, 8, 1, we subtract 2, 6. This is normal subtraction. Here we are not considering hexadecimal or octal or binary. So here, when we say 1 minus 6, it is not possible. We borrow here and we bring 1 here. Here we get 11, meaning we have borrowed 10. But we have not said 8 minus that 10, we get a negative 2. We decrease this 8 by 1, we get 7. Where number we'll take 7, we subtract 2, we get 5. And here we get 5. So in this case, now also in this, when we borrow here, we are going to take 16 to the next column, but for C is 13. So C is 12, sorry. So we are going to decrease it by 1, and we are going to remain with B. So we are remaining with B in this case. We remain with B because we have subtract 1 to get 11. So we are remaining with B. So in the second column we have b minus 1, and b is what? B is 11. We subtract 1, we get 10. We match 10 to our hexadecimal table, and we find that 10 is A. So in this column now we get A. We get A. Then the rest of the numbers, they are very simple. Since they are in between 0 and 15, we subtract them directly. 4 minus 1 is 3, and 1, that is 2 minus 1 is 1. So in this case, our answer is 13A D base 16. So that is how those hexadecimal operations are carried out. At your own time, look at the multiplication for the same. And also, you can also check the division for the same.